Welcome to Get Your FRQ On. This question is from 2009, Form B. It's question 2, and it is calculator active. In the question stem, we've got a storm washing away sand from a beach, which causes the edge of the water to get closer to a nearby road. The rate at which the distance between the road and the edge of the water is changing during the storm is modeled by a function f of t, which is given to us. The unit is meters per hour. T hours after the storm begins. We're also told that the edge of the water was 35 meters from the road when the storm began, and that the storm lasted for 5 hours. We are given the derivative of the function f, although it's not complicated. We probably could have come up with that on our own, but it is nice to be given the actual derivative. In part A of the question, we are asked what the distance between the road and the edge of the water is at the end of the storm. Now, since the edge of the water started 35 meters from the road when the storm began, and the distance from the edge of the water to the road changed at a rate which was given to us in the stem as f of t, meters per hour, the distance from the edge of the water to the road at the end of the storm is given by an integral expression. That distance is the integral from 0 to 5 of f of t dt. Now, since this is a calculator active question, we can use our calculator to evaluate that integral using the function provided to us in the question stem. The distance, which is the integral from 0 to 5 of f of t dt, would be the integral from 0 to 5 of the square root of t plus cosine t minus 3 dt, which is 26.495 meters. In part B of the question, we are given f prime of 4 equals 1.007, and we are asked to interpret the value of that and to provide units. Now, since f of t already represents a rate, the fact that f prime of 4 equals 1.007 represents a rate of a rate. So we're going to have to be very careful in terms of how we word this. So f prime of 4 equals 1.007 means that 4 hours into the storm, the rate at which the distance between the edge of the water and the road was increasing at a rate of 1.007 meters per hour per hour. In part C of this question, we are asked when the distance between the road and the edge of the water was decreasing most rapidly and to provide justification for our answer. Now, because this is a question about a maximum or minimum, in order to determine when f of t is at a maximum, we need to determine when its derivative, f prime of t, is equal to 0. Using a calculator to do this, we find that f prime of t is equal to 0 when t is equal to 0.66187 and 2.84038. Notice that I've named them with abbreviations T1 and T2. That will make it easier to refer to them later on in the solution to this problem. It's actually a really good idea when you're actually working on FRQs. So in order for f of t to have a maximum, this could happen at the two values of t we just found, or it could happen at one of the endpoints of the interval. So it could be at t equals 0 or t equals 5, but the two values t1 and t2 are also candidates. And since this is a calculator active question, we can use our calculator to evaluate for all of those values of t. F of 0 we find is -2. F of t1 is -1.39760. F of t2 is -2.26963. And f of 5 is -0.48027. So based on these calculations, the distance between the road and the edge of the water was decreasing most rapidly at t equals 2.84038 hours. In part D of this question, we are told that the distance between the road and edge of the water is growing at a rate g of p meters per day. This is because they've introduced a machine which is replacing sand into that affected area. P is the number of days since pumping began, and we are asked to write an integral equation to give the number of days that sand must be pumped to restore the original distance between the road and the edge of the water. Keep in mind, the original distance was 35 meters. Since the distance between the edge of the water and the road decreased by an amount equal to the integral from 0 to 5 of f of t dt, we need an integral from 0 to x of g of p dp to negate that change. In other words, we need it to undo everything that the storm did, and so we want those values to be equal. So translating that need into a calculus equation, we would get the integral from 0 to x of g of p dp minus the integral from 0 to 5 of f of t dt needs to equal 0. We do not need to solve this equation. Ideally, what we're writing is an equation where if we solved it, we would get that desired value, but we do not need to solve it. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.